Hi class. So last time we talked about cake division and we looked at the method of you cut, I choose. And we talked about it in terms of being a fair way to divide up a cake between two people. And if you remember, what did we mean by fair? Well, it wasn't actually equitable, and it wasn't actually Pareto optimal necessarily, but it was proportional, right? In the sense that everyone got at least half of the cake in their own eyes. And we analyzed cake divisions for 3 people, but we didn't actually talk about what is a good way to divide up cake between 3 people, right? I just gave you a division and we looked at, is this division proportional? Is it equitable? Envy-free, Pareto optimal? But we never talked about how we might arrive at such a nice division. Today what we're going to talk about is a way to split cake between 3 people, not 2 people, that's still proportional, right? And so this was invented by Steinhaus, and so it's called the Steinhaus Proportional Procedure, okay? And so I'm going to show you down here an outline of the procedure, but it's a little bit hard to just talk through. So what I'd like to show you is an example of how it works. But keep in mind that these are the steps here, all right? I'll read through the steps, but I'll also do a visual demonstration so you can see just how it works. The first step is that player 1 is going to cut the cake into 3 pieces, right? So again, there's one person who's designated as the cake cutter. And so they're going to cut the cake into 3 pieces. And what's important to know is that they have no choice over which piece they get. They're eventually going to just get the last piece available. So they should cut the cake in a way that they think each cake piece is equal in value. Just like with the you cut, I choose, the first cutter was cutting in a way to make sure half of the cake was in each piece. In the same way, player 1 is going to cut the cake to guarantee that a third of the cake is in each piece. Then what do? You move on to the next player, and they're going to approve of one of the pieces, right? So they are going to look, and they're going to find one piece that they like the most, or maybe they find 2 pieces that they both like. And what they're going to do is just say, okay, I would like that piece or that other piece. But they don't get that piece yet. They just approve of a piece, and then we move on. What's going to happen next is that player 3 is also going to approve of at least one piece. Again, they can choose multiple pieces that they approve of. That's fine. But again, they don't get those pieces yet. What happens then is that we branch into 2 different things. All right, so either step 4 will happen or step 5 will happen. So if player 2 and player 3 approve of different pieces, then perfect. Give player 3 what he approved of, give player 2 what she approved of, and then player 1 gets the last piece. But there's going to be a complication. What if player 2 and player 3 only like the same piece, right? Then what do we do with that piece? What's going to happen is that player 1 is going to get one of the pieces that they don't like. Okay, so in here we're calling the piece that they like X. They both like only X. Player 1 likes Z, so player 1 will take a different piece and call it Z. Then the last remaining piece, I guess we're calling it Y here, is going to be combined with the piece that they like. That is the piece that both player 2 and player 3 approved. And so we're going to create this new cake called XY. And what's going to happen is that now player 1 is out of the picture, right? Player 1 already got their piece. They're happy with their piece because player 1 cut it in a way that they'd be happy with any piece. And now we have 2 people left trying to divide up a cake proportionally. And we already know how to do that, right? You just do another you cut, you choose. You cut, I choose. So player 2 and player 3 will do a cut and choose on this combined cake XY. Again, sometimes this procedure works out really nicely, right? Where you just have everyone likes a different piece, and then that's really, really easy. But we have this extra clause that if player 2 and player 3 only like the same piece, then they can go ahead and still resolve the problem in a proportional way. Okay, so what I'd like to do now is just do a video demonstration of how this works. I know that it was probably kind of hard to just follow along with me describing this out. So what I'm going to do is just show you on a real cake. All right, so here we are. Baked this beautiful cake. All right, it's a miniature cake. I can give you the recipe later. All right, I really need 2 people here to help me with it, but you know, social distancing and all, I'm just gonna pretend to be 3 people. All right, so here we go. Nice, beautiful cake. All right, wow, looks great. So I'm gonna be player 1 first, and then I'll tell you what player 2 and player 3 are gonna do. Okay, so let's act out the simple scenario first. Player 1 looks at the cake and decides that he's gonna cut it in a way that he'd be satisfied with any of the 3 pieces. Okay, so let's go. Now, as player 1, I really like these flowers here. So I'm going to make sure that there's 1 flower in each piece. Okay, so there we go. That's the first piece. That's the second piece. And if I don't get a flower, if I don't get a flower, I'm going to make sure that I at least get a lot of cake. Okay, so you can see that this piece over here I made a little bit bigger to kind of compensate for the fact that I might not get that flower. All right. Okay, so yeah, it's delicious. It's a chocolate cake, if you're wondering. Okay, so now player 1 would be okay with getting any of these 3 pieces. So we move on to player 2. Now player 2 says, okay, which piece would I like? So player 2, say player 2 really just likes volume over anything. So say player 2 is going to get this cake over here. I'll mark it with a little X on top of it, right? And that's the only piece that player 2 likes, because it's just the biggest, so player 2 likes it the most. What about player 3? Player 3 really likes flowers, just like player 1, and so it actually decides that he's going to take this piece over here. Okay. And then, so what's going to happen? Well, we're in that first scenario where player 2 and player 3 approved of different pieces, so the division is really easy. Okay, player 2 gets the piece they want, player 3 gets the piece they want, and player 1 gets a piece that's left over. Right. And so that's Steinhaus's proportional procedure, the easy case. Okay, so let's do the harder case instead, the more complicated case. All right, so we'll erase these little markings that we had up top here. And okay, player 1 still cuts it the same way, right? Because player 1 still thinks that these 3 pieces are equal. Okay, so now we go to player 2 to approve of a piece. Oh, my beautiful cake. That flower took a lot of time to make. Okay, so player 2, again, will say likes volume over anything. Okay, and so player 2 is like, well, I still like this piece over there. And player 3 now, instead of liking flowers, okay, player 3 also likes just more cake, right? Isn't concerned about getting a little flour on their cake. Who cares? Really, it's just sugar, right? You really want that floury, doughy cake, right? That's good, right? Like, again, this is a no flour cake actually, because we ran out of groceries. Okay, so say player 3 also wants this one. Okay, so both player 2 and player 3 want this one, right? Now what's going to happen? Well, they can't just split that one, because then player 1 would get way too much. Okay, so instead, what's going to happen is that player 1 is going to say, okay, well, you'll both like that one the most, so I'm going to take this one. Right? Player 1 just gets to choose whatever they want out of the 2 pieces that remain. Okay, so we set that one aside for player 1. Now, player 2 and player 3, they want to split this, but they're going to combine these 2 pieces together. Okay. So player 2 and player 3 with this combined cake are going to play you cut, I choose. So give me a second. I'm gonna glue this cake a little back together. All right, don't worry, I washed my hands. Okay. So we just treat these two slices, that's a new cake. Okay. Great. All right. You can sort of see the seam there. Oh, my flour. Okay. So this is the piece that I guess we called XY in that list. And player 1's all set. They have their piece. But now we have this cake here that player 2 and player 3 need to split. Okay. So either one can be the cutter, either one can be the chooser, doesn't matter. Let's just say player 2 is the cutter, right? So player 2 looks at this and is like, okay, well, I'm just going for cake volume and I don't care about that flour at all. And so player 2 is going to cut maybe right there, right? To cut the cake in half. Now notice the old line was there. Now we're going to cut here instead. Right. You know, I tried to decorate this cake, make it beautiful for you. It's really giving me a headache now. Okay, so player 2 is going to recut the cake. Okay. And they do their best job to make sure that both sides are about equal, right? I mean, you can be the judge for yourself whether or not you think those are equal or not, but notice that part of that original piece they both approved, player 2 cut off and get added to the piece that they didn't approve of. And so player 2 is like, okay, these are about the same size, so I'm okay with either one of these. So player 2 is the cutter, and you cut, I choose. Now player 3 approaches the slices, all right, grabs them, looks at them, and says, okay, well, you know, I guess I'm gonna choose this one on the left over here, this player 3, right? Because, you know, I don't really care that much about the flour, but if I have the choice over flour over no flour, I'm gonna go for the flour. Okay, so player 3 ends up taking this piece, and then this leftover piece now goes to player 2. And now, so what happened? Well, player 1 was dealt with in the beginning, and it was reduced down to a scenario with 2 players that we knew how to solve using the you cut, I choose method. Okay, and that's Steinhaus's proportional procedure. It is proportional because player 1 got at least a third. They would have been happy with any piece. And it's proportional for player 2 and player 3 because the combined total of these two pieces was at least 2/3 of the cake, and then they split it in half. So you have something that's at least 1/3 for both of them. Okay, and there's one more thing I want to talk about while we're here with these cakes in front of us, is that this process actually can still induce envy, all right? Because if we take a look at these pieces now, right? Player 2 and player 3 aren't going to be envious of one another because player 3 got to choose first, and player 2 was happy with either of those two slices. But this first player might be envious of the new slices that were made. So let's think about why. Okay, player 1 slice is this big. Now if we just look at these two slices, if we just look at these two slices, right, player 1 was okay when this slice was only this big, right? Then player 1 thought that piece was equal to his piece. But all of a sudden, player 3 is getting that much, plus a little bit more. So player 1 would love to switch pieces with this one, right? It's got that flour that player 1's looking for, but it also has an extra little bit of cake compared to his piece. So player 1 can be envious of how the division happens between player 2 and player 3. Right? Player 1 was removed from the picture. Player 1 never got to put any input into the you cut, I choose that player 2 and player 3 did. So there could still be some envy in this procedure. All right? It is proportional. Everyone got at least 1/3. It might not be equitable for the same reason why you cut, I choose is not equitable, but also it might not be envy free. Okay, there could still be envy on the side of player 1 to player 2 and player 3. Okay, so hopefully you understand a little bit better how this procedure works. Okay, again, there's 3 roles now. There's the first player who's the cutter, and there's 2 choosers. All right, and again, they don't just get to grab whatever they want. They have to approve of the pieces first, and they need to see whether or not their approvals differ or whether they're the same. And we have two different scenarios depending on what might happen. So let's look at some examples that might come up and how we might solve problems that arise using Steinhaus's proportional procedure. All right, so say we have a cake, okay? And we're gonna have player 1, player 2, and player 3. Player 1, again, we'll just say that they're the cutter. Okay. And suppose that player 1 makes the cuts like this. For whatever reason, player 1 thinks that these three pieces are equal. Again, maybe there's a little flower on this one, makes it slightly better than player 1, for whatever reason, okay? We'll call this piece X, we'll call this piece Y, and call this piece Z. And what I'm going to do is just make a little chart that tells you how each player rates the pieces. So player 1, right, again, player 1 making the cuts has to imagine that all three of these pieces is exactly 1/3 of the total cake. In value, not in size, right? Again, the piece Y is smaller, but the flower adds a little bit of extra value to it. Right? So player 1 thinks that all of these are equal. Okay, well, what does player 2 think? Well, player 2 thinks that piece X is 40%, piece Y is only 20%, and piece Z is 40%. So, player 2 has no preference between piece X and piece Z, but doesn't like the fact that piece Y is just a little bit small. Okay, so in this process, player 2 would approve of both piece X and piece Z. What about player 3? Player 3 takes a look at the cakes and says, okay, well, I like piece X 40%. I like piece Y 30%. And I like piece Z 30%. Okay, who knows? Maybe piece X is just got like a little extra frosting, and besides that, player 3 doesn't really care. Right? Well, which piece is he going to approve of? He's going to approve of the one that he thinks is the best. So player 3 is going to approve of this 40% piece. And so now, what's the division that we're going to use? Well, okay, you might be thinking to yourself, player 2 and player 3 approved of the same piece, right? They both like piece X. So what are we going to do? Do we have to do that whole scenario where we're putting things back together? And the answer is actually no, we don't. Because even though they do both approve of X, there's at least one piece that player 2 likes that player 3 doesn't like, and that's Z. So piece Z will just go to player 2. That way, it frees up piece X to go to player 3. And finally, player 1 is left with piece Y. And if we look, everyone is happy. Player 1 got at least 33%, player 2 got at least 33%, player 3 got at least 33%. So each person got at least 1/3 of the total value, right? They're all greater or equal to 33% of the total cake. Okay, I guess, 33.3333, whatever. So this is an example of the simple scenario for Steinhaus's proportional procedure. Player 2 and player 3 approved of different pieces. Again, they also approved of the same piece, but there was two pieces that were different that they approved of. So it's easy to hand out the pieces. Okay, so let's look at a scenario where it's not quite as simple. So let's say instead, okay, we can have the same division, by the way. So we got piece X, piece Y, piece Z. Player 1 was the cutter. Player 2 and player 3 are sitting over there. And let's suppose that they actually liked these pieces a little bit differently than before. So again, player 1 will always like each of the pieces 33.3%. If player 1 didn't like them all 33.3%, then he or she just made the wrong cut. Player 1 gets to cut, so they should choose cuts that make sure that they're fine with everything else. If they mess up, then that's their fault, they mess up. But otherwise, we can always assume player 1 likes all the pieces equally. Okay, so 1/3. Now let's say, again, player 2, well, let's flip things a little bit around. Player 2 says, oh, I really like that flower. All right, so I really think piece Y is great. I think it's 20% of the whole cake. And piece X and piece Z, okay, they're fine, but I gotta have that flower on my cake. All right, so piece X and piece Z, those are about 25%. Player 2 does not like them. What about player 3? Well, player 3, turns out that player 3 also likes flowers. Okay, maybe not as much as player 2, but you can see that player 3 likes the flower piece more than the other pieces. In this case, only 40%. Okay, so player 2 will approve of piece Y. Player 3 will also approve of piece Y. And now we're in that scenario, right? Neither of them want either piece X or piece C, so they approve of the same piece. Uh-oh. Okay, so how do we resolve this? Well, again, if they approve of the same piece, then we're gonna just make player 1 happy. Player 1 gets to choose either piece X or piece Z, right? So player 1 is like, okay, well, there are less fingerprints on piece X. So I'll take piece X. Okay, great. So that is removed from the whole scenario. And now with piece Y and piece Z, okay, this remaining cake, this gets combined to a new cake. And player 2 and player 3 now need to play you cut, I choose on this. So just player 2 and player 3 will play you cut, I choose. So we'll call this round 2. We just have player 2 and player 3. And player 2 decides that, okay, in order to make the piece with the flower equal to the piece without the flower, I'm going to have to recut it to be a little bit smaller. All right, so now we have this new piece here and this new piece here. Oh, what should we call them? I guess we'll call them piece A and piece B. Player 2, being the cutter, okay, again, must have split this in a way that they believe both of these pieces are equal. So now with this new remaining cake, player 2 thinks these two slices A and B are the same. Right? What about player 3? Well, player 3 didn't really like the flower that much. So after this recut, player 3 only likes piece A, 40% of the remaining cake, and actually thinks that piece B is just better. All right, I mean, getting that extra cake really offsets the fact that they don't get the flower. Okay, so what do they do? Again, player 2 was the cutter, so player 3 gets to choose, and player 3 will end up with piece B. Okay, so at the end of the day, player 1 got piece X, player 2 got piece A, player 3 gets piece B. Okay, and it's a little bit weird, right? We have pieces X, A, and B, and well, A and B are really kind of different than X, Y, and Z. If we looked at our original diagram, right, piece A was kind of just this piece up here, right? This was A, then this piece down here was B. But at the end of the day, everyone thinks that they got at least 1/3 of the cake, so this was proportional. We were able to resolve the conflict between player 2 and player 3, only liking the same piece, and ended up with a solution that made it proportional to everybody. Notice that if we had just given player 2 piece Y and said, okay, player 3, you can end up with piece Z, right? Well, what would have happened? It would not have been proportional, since player 3 only got 30% of the cake. They didn't get 33.3% of the cake. Finally, let's talk about the issue of envy. So, does anyone envy anyone else? Well, first of all, player 2 doesn't envy anyone because they think that player 1 got the smallest piece and they were fine between either of these two pieces, so they don't envy the piece that player 3 took. Player 3 isn't going to envy player 1 for the same reason. They didn't think the piece that player 1 got was any good, and they think that they did better now because they got the first pick. But player 1 might envy somebody. So who might that be? Well, again, think about back to the original division. Player 1 thought that the original 3 slices were all equal. But look what player 2 did once he recut it. He gave that extra little piece, he gave it over there. So if player 1 were still able to choose, player 1 would have been screaming, hey, I want piece Z now, or the new piece Z. I want piece B, because it's just bigger than the piece Z that was equal to piece X. So player 1 might re-rate those pieces at kind of a higher value. And so player 1 actually does envy player 3. Since piece B was bigger than piece Y, which was equal to piece X. So again, in P1's eyes, piece X equals piece Y equals piece Z, but piece B was gotten by just adding on to piece Y. So piece B was bigger than piece Y, and so therefore it's also bigger than piece X and piece Z. So piece B is bigger than piece X. All right, and there you have it. That's Steinhaus's proportional procedure. All right, now if you're sitting home, you're an only child, your mom and dad are there, you got a slice of cake sitting out. Dad's like, oh, I'll just make the cuts and give anyone whoever they want. You can sit there and say, nuh-uh, all right, I learned about this, okay? I'll be the cutter. And you can explain all these rules, they can figure it out. Great. And that's about it. Thanks for listening. Give the worksheet a shot. You're going to try to work through some of these problems. I'll give you diagrams to show you how players think different pieces of cake are worth, and you can go ahead and try to see what decisions they would make in terms of choosing pieces, approving of pieces, splitting pieces, so on and so forth. Okay? And I'll see you later.